Welcome everybody, and thank you for joining our Geomagic Product Spotlight webinar. This webinar is focused on mesh creation types in Geomagic Design X and Control X. I appreciate you joining us today, and I hope you'll be able to join us on future Product Spotlight webinars as well. A few housekeeping items before we get started. As you may have noticed, all attendees' lines were muted upon joining the webinar. Therefore, please use the Q&A button on your screen to submit any questions as we go along. In an effort to abide by our 20-minute time allotment, we will not address questions live during the webinar. However, we will follow up with you after the webinar with an answer to your question. Additionally, we will make the answers to all frequently asked questions available for all of you who have attended. Finally, in a couple of days, you'll be receiving a follow-up email with a link to view the recording of this webinar, as well as a sample file that can be used to trial the process being demonstrated today. Once again, thank you for joining us. I will now pass it on to Jeff Moody, a Geomagic application engineer, as he'll be leading today's demonstration. Jeff, it's all yours.
Thank you, Adam. Hello, everyone. Once again, my name is Jeff Moody. I'm an applications engineer with 3D Systems Software, and today I'm going to be demonstrating how to convert point clouds into polygonal mesh. On the left-hand side here, we have a point cloud that's basically XYZ points. And in the middle, we're going to use these two tools, triangulate and merge, to convert them into mesh objects. Basically, we're going to draw lines between points and add faces to that to create a mesh. These two tools are available both in Control X and Design X. The algorithms are the same for both softwares. The difference is Control X is an inspection software and Design X is a reverse engineering software. In these two tools, we have several different methods for dealing with any situation that you might come across, whether it be single scan pass, multiple scan passes, sparse scan data, or long-range scan data. On the right-hand side are the supported point cloud file formats. The most useful are ASCII point clouds or PTS, PTX file formats. So let's talk about our first tool. Triangulation deals with single point clouds at a time. It has 4 different methods: 2D triangulation, 3D triangulation, mesh construction, and HD mesh construction. 2D triangulation takes a look at the point cloud, projects it to a digital plane, triangulates it on that digital plane, then repositions it back to its previous position. 3D triangulation takes a look at the point cloud, looks at the smallest distance between 2 points, triangulates that, then triangulates the next largest, so on and so forth. Mesh construction creates a topological mesh structure following the geometric shape of the point cloud. A useful note here is this tool is trying to create a uniform poly-edge length. HD mesh construction creates a voxel mesh structure derived from the point cloud. Not only is it trying to create a mesh object, but it's also trying to fill holes simultaneously. In our next tool, merge, it deals with multiple point clouds in one shot, so you don't have to do additional operations. There's 3 different methods: volume merge, mesh construction, and HD mesh construction. Volume merge takes a look at 2 different point clouds, converts them to volumes, then divides that volume to give us this nice gradient edge instead of a straight up and down edge. Mesh construction and HD mesh construction are the exact same as in triangulation. However, in merge, they can deal with multiple point clouds at once. So let's start our demonstration. Here we have a part made up of 17 different point clouds. I'll go ahead and hide all these point clouds by right-clicking on the parent and selecting Hide. I'll then go into the Points tab, select Triangulation, select 2D Triangulation as my method, and then select my first point cloud. The useful thing to note about this is the direction. The scan direction is given here, and it's kind of a generic scan direction, but I want to find the correct direction, the correct orientation in which it was scanned. So I'll choose Find Scan Direction. Here it's pointed towards the bottom, but in fact we want this arrow pointing at the scan head itself. I know that I scanned this up here somewhere, so I will click this arrow and invert it. I'll then say OK to my triangulation, and it will create a mesh object. If I expand this, it shows that this first point cloud is now a mesh object and that it's blue. That indicates that the normals are in the correct orientation. If I rotate to the back side here, it's showing the brown color, which is the opposite direction. A useful tool in 2D triangulation is that it only deals with one point cloud at a time, but I can deal with multiple point clouds simultaneously. So I'm going to be working with 4 point clouds individually, which will then result in 4 mesh objects. So again, I'm going to find scan direction. I see that the first 3 have oriented correctly, however the 4th one is not. All I have to do is click this arrow to orient it into the correct direction, and then say OK. This will result in 4 brand new meshes. I can then left click on the eye, holding it, and drag and turn off all of these point clouds, or all of these meshes dynamically. So let's move on to our next method in triangulation, and that will be 3D triangulation. This tool is useful when you have multiple point clouds combined ahead of time and can no longer use 2D triangulation as your triangulation method. Again, this is going to look at the distances from shortest to largest, and that's displayed here once I estimate the distance criteria to connect vertices. If I want to change this to a round number, I can double-click, highlight that number, and enter a given number. I will then go ahead and say OK, and we'll create a new mesh object. Turn that off. Our next method is mesh construction. So again, this is trying to create uniform poly edge lengths, and they can be controlled by geometry capture accuracy and the scanner accuracy. So I'll turn on my first point cloud number 7, and I'll set this to loose so we can see what's going on. Say OK. So we should see rather large triangles, and in fact we do. But if I turn on the triangulation and I set my geometry capture accuracy to tight, it's going to put in as many triangles as possible in there. And on top of that, I will select reduce noise to remove any unwanted points. We'll go up here to the top and select only point cloud 8. And the result will be a new mesh object. Perfect. So let's move on to our next method in triangulation. Here we have sparse data. Here we have sparse data. And if I open up, I see that I have 70,000 points, 71,000 points, and my next point cloud has 150,000 points. So this is a pretty sparse scan set. I'm going to set my I'm going to go into HD mesh construction, set my high definition filter to SD, set my noise reduction to medium, and set my extend boundaries to fill holes to less, because I don't want to fill any holes. I simply want to work with what I have available. So I'll select the point cloud, and then I will say OK. So here you can see that it did not fill any boundaries, and it's created a smooth, flat surface, even though this is sparse data. This works well with sparse data as well as long-range data. Next, we'll go into the second tool, merge, and we'll use volume merge to merge all of these last few point clouds. Here, select merge, turn them on. There we go. Holding Shift, I'll select the first one and last one to get all of the point clouds. I'll leave my geometry capture accuracy where it's at, and then I'll select estimate number of faces. 600,000 faces is acceptable. I'll go ahead and hit OK, and we'll view the results. In addition to this, if I wanted to keep these point clouds as they were, I could have unchecked remove original data. That would have left me with all of the point clouds as well as this new mesh object. Here we can see that this mesh object has been combined during the merge operation, which resulted in all of these being combined. Let's move on to our large data set. So here we have a large data set taken by a LiDAR scanner. We have 14 different shots to make up this scan. If I hold Shift and select all of these scans and go over to Properties, I can see that I have 51 million points. So this is a very large number to try and merge or triangulate. So I'm going to cut it down just a bit. I want to work on this, the front face of this house, so I'm going to just select that and copy it. So once again, I'll be in the points. I'll use my box selection here. Select Control-C to copy the face, or to copy the points, and then Control-V to apply it as a copied point cloud. I'll go ahead and right-click and hide all of my points. Turn on the copy, and view my results. My textures are still displayed, so I will go into my display, turn off textures just to see the raw points. So again, I can go back into Triangulate, select HD Mesh Construction, turn my HD filter to 75%, my noise reduction level to about 60%, and my extend boundaries to fill holes to about 50%, about 60%. I'll then select my copied point cloud, and then I will hit Triangulate. However, this takes a little bit of time, so I've done this ahead of time. I'll close this out so we can view our resulting mesh. And here is the result. So again, the underlying voxel structure created this kind of wraparound effect to attempt to close this boundary. However, it was too large to close, so this is what we came up with. Where it was able to close was these windows, this light, these lights, and this window here. Lastly, in addition, if we want to use a sparse data set such as a LiDAR scan, and we want to use a dense data set such as the artifact that we had earlier, and we want to combine the two, we can do the same thing. Just select the two different point clouds. I'll keep my same settings. And this one, I will leave my HD filter on 75%, my noise reduction on 60%, my extend boundaries to fill holes at about 60% as well. And again, this takes a little bit of time, so I've done it ahead of time so we can view the result here. Now again, I will turn off my point clouds and view the resulting mesh. And sure enough, the artifact is on the porch. So we can continue on doing, continue on modeling with this by setting reference geometry on here and constructing whatever we need to. So back to this. For more information or about the software applications, please visit 3dsystems.com. For sales information and pricing, please email geomagic.sales.americas@3dsystems.com. To download a trial or for technical support, please visit gettingstarted@geomagic.com. And that concludes my demonstration, and with that, I'll hand it back over to Adam.
Thanks, Jeff. This brings us to the end of our Geomagic Product Spotlight webinar on mesh creation types in Geomagic Design X and Control X. Please be on the lookout for invitations to future product spotlights from 3D Systems. In the coming days, each of you will receive an email with a link to the recorded version of this webinar, as well as some useful links regarding Geomagic products and answers to frequently asked questions. If you ask a specific question during the webinar, we'll be sure to follow up with you with an answer in a timely manner. Thank you again for joining us, and have a good rest of your day.